Raspberry Pi and circuit simulation. Falstad simulator, boost switch mode power supply. We're going to open up a web browser. Go to Falstad. And here is the circuit simulator. We shall go to the full screen version. We'll change the circuit to a power converter, and we'll look at the boost circuit. Now, to give ourselves more room for the oscilloscope display portion, we'll just move the circuit to the top of the display. And then we can move the display up somewhat. Now here we see two oscilloscope displays. And because we're going to be looking at currents in the various circuit components, we'd really like to see what's happening simultaneously. So we're just going to rearrange the scopes to the stack all mode. Now the simulation is moving fairly fast. It's a little bit hard to see what's going on, so I'll just slow it down a little bit. There we go. Now the first display you see here is showing us by default this oscillator here. And so we're going to give that a name. We go to Properties. We're not going to bother with the RMS value of it. We'll give it a label. We'll call it a clock, because these kind of circuits have a clock. And there it is. This bottom trace over here happens to be the output. You can see the number displayed over here. And when we put the cursor into that particular window, you notice that it pops up and says output right up here. And it's looking rather low. So what we're going to do is we'll just change that slightly. We'll go to Properties. And it's showing us the RMS value, which is fine. But what we'd like to do is zoom in on the ripple. So we'll just click that and notice what happens. Now it's automatically just looking at the AC portion of the waveform. Now we're not particularly interested in what's happening here. Now notice that the display is showing an awful lot of cycles. We'd like to zoom in on it. Now we can do that by going to the properties of the traces again and adjust the horizontal scale. Now here's something interesting. Notice we can only go to 100 microseconds per division. So we'll apply that. But we haven't really zoomed in all that much on the display. We'd like to actually zoom in a little bit more. The second thing you'll notice is that the output ripple over here, it doesn't quite look right. It's not filling up the whole display. Well, that's because the circuit is going to take some time to go through its calculations again. We can speed the whole thing up by just running a simulation faster and slowing it down again, and now you can see the display looks more like it did before. We see the ripple. Next, we'd like to zoom in on the display. We can do that by going to Options, Other Options, and changing. Notice it says time step over here. It also says time step over here of 5 microseconds. This is the time step used internally to do the calculations. We're going to speed that up to 1 microsecond. Apply that. Okay. And notice what happens. You can just see it happening here. We've zoomed in a bit. And again, we'll just speed it up temporarily. Now you can see what's happened. We've really zoomed in on the display. Well, maybe we've zoomed in a little bit more than what we wanted to. So let's just go back to the properties here and drop this. Now it went to 20 microseconds revision. Let's drop it down to 50. Okay. And again, we notice what happens if we speed it up and slow it down. We see now just 2 cycles of the display. So that's really, we've zoomed in quite nicely. So let's just get rid of the ripple here by just removing the plot. And we're going to click on to the inductor over here. Right mouse click on the inductor. View in new scope. And notice what happens. It's automatically created 2 scope windows side by side. Well, again, we'd rather see what's happening simultaneously with both. So now, what does this waveform represent? Well, let's just take a look at what we can choose. The properties of that trace. We are showing the current, which is what we want. We want to see the scale. We don't need to see the duty cycle that's already shown on the clock. And we're going to label this as the inductor current. Okay. And if we speed it up again and slow it down, you can see, again, we're actually just looking at the ripple in the inductor current, and that's because in the properties we left it at auto max scale. What that really means is that we're only looking at the change in the waveform, or we've zoomed in on it. So there we have it, inductor current. Now let's add the current through the switch or the MOSFET device. So we're going to view in a new scope. And again, we're going to stack it. And we're going to call this the MOSFET current. Don't need to show the duty cycle. We've already got the max scale. So this is the MOSFET current. Okay. Now we're going to add the diode current. Stack the display. Look at its properties. We're going to call it the diode current. Okay. And we'd like to add the capacitor current, so we're going to view in a new scope, stack the display, go to properties, label it as the capacitor current. And there we have the principal current waveforms. And we're going to stop it, let's say right about here. And there we can see the relationship between all the currents in this simplified model. Now we can add a label to this up here. We can do that by going to Draw and put in a label, text. And we're going to call this, edit it, we're going to call it the boost switch mode power supply. Wow. Make the font a little smaller, apply it. Okay. There it is. Now, as a student, of course, you want to be able to collect these results and make your own notes of some sort. And this program allows you to do that very easily. Of course, on the Raspberry Pi, you can open up a word processing document, which comes with the program. And you can also open up a screenshot program. But this program also allows you to do things like export as an image. So you can capture the image of this thing and put it into your document. But notice also it has export as a link. This is very useful. If you click that, you notice it creates a URL for this circuit. But it's more than just a US URL for the Falstad program. This code over here includes everything which is needed to reproduce this model and the displays you've just created. So if you copy that to clipboard and paste that into your text document, then automatically when you click that as a hyperlink, it will open this up and you'll see this. So you don't have to redo all the work from the beginning. It's already done for you. This code remembers it all for you. And if you've inserted the image into the Office Writer, this is what it looks like. And then if you click the URL that you've embedded, the program opens up and runs. And here are a few notes which explain how the circuit works.